Hello and welcome to Section 3, How to Enhance Your Code with Generics. In this episode, we're going to talk about type constraints, key points, enforce certain limitations on the types that can be used with generic functions and generic types. So sometimes we can't use a totally generic value. We have to be able to limit it in some sort of way. I'm going to show you an example now, which will make it clear to you. Okay, so for an example, we're going to make a function that tells you if a value is inside an array. So first of all, we'll make it without using generics, and then I'll show you how to extend it with generics, and then we'll add type constraints. So first, let's define a function called exists. It's going to take in an item of type string. This is the item we want to find within an array. Then we define the array as type string too. And then we return boolean to represent if it's there or not. So this is a simple function. We're just going to loop through every value in the array and return true if that item is equal to the array item. If we get to the end of that loop and there's no value, then we return false. So this is our function. There's no generics. This is strictly limited to strings. And if we were to, first of all, define a test string, a test string array, with A and B, we can use our function exists to see if, first of all, A is in there, which it is, or maybe one is not there, T, and it returns false. So if you want to make this generic, we would like to be able to use any type rather than string, maybe an integer. So we will update this function now to allow us to do that. So first of all, with generic types, you define your own custom type at the start. We're going to call it T. And then item has to conform. Item has to be that type. So we will remove string and give type T. And the array is going to be an array of our type. So T can represent anything, string, integer, or whatever you like. And it's still going to return bool to say if it's in there or not. So we're getting an error now because binary operator equals cannot be applied to two T operands. So this is because this equals is not defined in our new type T, so we have to type constrain it into a type that conforms to the protocol that contains that. So that protocol is called equatable. Now if we go into that, you can see that it adds the equals function, so you can compare two values. So the only types now that this function can take have to be conformant to equatable, which is really handy for us because we're checking if they're equal to each other here. So this here example should work. It's gathering the type T from this string you passed in, so it knows automatically through type inference that this type is string. So T here will be replaced with string everywhere you see it. You can just do that in your mind's eye, you can see. And if we were to pass in, so say it's false, let's check if it works first. So we do A again, prints out true, so that's fine. And if this was not a string array and maybe an integer array, let's just keep it called array. This will not work because it expects string because it's inferring from the first value. So you have to pass in the right type, so it constrains itself that way, which is quite nice. So we'll do 2, and there you go, 2 is there. And this is a fully generic function now. And we do 3, it won't be there. So this is a quick example of a generic function that has a type constraint of equatable. And hopefully that gives you an idea of what's going on here and what you can do to constrain your code. Later on, we'll go through more complicated examples, but this will get you going. So this has been a video about type constraints and a little bit about generic parameters.